Hi everyone, thanks for joining. We're going to do something a little different here today. Instead of presenting a full solution, we're simply going to provide a little bit of training how to grapple with underlying data tables, specifically how to calendarize a basic data table. So we're going to start with the end in mind, and so this is where we're going to end up. This chart here illustrates the rundown of the old maintenance charges, and this is the ramp up of the new maintenance charges. Here's the illustration of CapEx occurring over some period of time, sliceable by regions and site. So this is where we're going to end up. We're going to enable that from this quite ugly table. This is a standard table, and we'll get into that in a little bit. So the lesson plan and the approach is we're going to learn to recognize the attributes of the presenting table and some of the reshaping requirements needed to calendarize the data. We're going to look at the traditional Excel approach, understand the scalability, flexibility, limitations of that solution. We're going to break it into some components: a staging table, base table, calendarize. We're going to look at the data model quickly. And then we're going to illustrate how DAX Studio can help assemble various expressions. And finally, we're going to spend a little bit of time on Power BI, and we're going to examine how to make these visuals available on a mobile device. You can see here we've got a standard, pretty standard data set, slimmed down. We've got 10 unique site codes, and we've got 30 devices. We've got dollars. This represents the CapEx sequence. You can see the EOL date here. So on January 30th, this new device was put in, and the maintenance rate went from $895 to $118. Similarly here, 324, we had a device go in, and the rate went from 1100 or so to 1400. So this is pretty typical, right? You've got stop-start date, so this represents the start of the period and the end of the period. In this case, it could be a maintenance contract, or it could be the term of the deal. And in this case, it's the actual transaction point. So in Excel, the way the conversion happens is people simply do conditional expressions all the way out. And in this case, it's 36 months. So it's 36 months for the run rate piece of it. You can see we have columns hidden here, and we've got 36-month CapEx piece of it. You can see that even in a very small 30-device model, you can sort of calendarize it with VLOOKUPs and sub-ifs, and you can cobble it together. It is completely unwieldy at 25,000, 30,000 rows. At that scale, you're looking at something over 3 million data points, 3.6 million data points. And if you had other charge type, that would set of 60 columns, assuming it's a 5-year implementation. So clearly this is unwieldy and really can't be scaled very well. So you can see here, this is the staging table. So what we've done is simply attach an end of month label to the transition date, and we do it as a data modeling artifact. These 3 columns will get dropped, and we'll see that in a little bit. So we add an index column, which represents a primary key, and we added a month number, as I indicate here. Sequential month numbers are very helpful when dealing with complexities of different charge types. So that's staging. Let's move on to base table. You can see here, we've simply retained the row elements of the staging table. Calendarize really means retaining the cross-tabulated portion of the staging table. It's important that the column counts be kept to a minimum. And you can see here we've dropped, 3 or 4 of them, right? Start, EOL, and month number were dropped. And the Microsoft Vertipack engine really works best with tables that are narrow and tall. We can see here a new column called expand, and this was added during the Depivot. So the table is expanded vertically based on the number of row elements, which in our case, we're looking at 30 rows, right? So we think of it as the 36-month amortization times the number of rows. It's really a Cartesian product of that, roughly 1,000 rows in this model. We're going to do a simple manual calculation here. You can see we're simply saying that if the expand is equal to the end of month, we're going to pick up the CapEx value. Otherwise, it's going to be a null. So here we do the same thing. So we got a bunch of nulls and this. So this one here is a little different, which is we're saying that if the expand is greater than end of month, you can pick up the new. Otherwise, we're going to pick up the old. Each row has got a value in it based on when the transition date is. Right. So we go all the way down. You can see the 1270 synced up with our Excel manual calculation. We're going to compare and contrast 2 different ways of doing this in the data model. You can see here, this is our calendarized table. We're going to attempt to replicate what we did manually. So if expand is equal to EOM, we pick up a CapEx. Otherwise, blank. And let's close that off. Let's do the next one, which is if expand is greater than EOM, then we want to pick up the new. Otherwise, we default to the old, close it off. So we're going to call this Excel CapEx, and we're going to call this Excel run rate. I say that somewhat pejoratively because to simply use calculated columns in a data model, really you've defeated the entire purpose of the model. If this were 2 million rows, this takes up very valuable memory real estate, and the model begins to slow down as you populate calculated columns horizontally. Yes, you could simply do something as easy as this. So this will show up in the model. What I'm attempting to suggest here is that calculated columns generate an answer. And for smaller situations, you actually don't need a data model. You could have done it easily enough simply in Excel. This really doesn't scale very well. Your model gets clogged down. You really want to develop measures that will not take up the valuable memory real estate that is being occupied here with calculated columns. We'll bring up our DAX application. This is a workbench. You can see we're going to connect to the model here. Here we've got our tables. Here we've got some functions, and I do want to bring in some functions that we had developed previously. So this starts with an evaluate statement, and we want to bring in, let's try and bring in our major table here. This is where the table shaping occurs. Hit run. And you can see we have a complete expression of the calendarized table. In this case, it's a little over 1,000 rows. It's pretty simple. So this is where we want to begin to build our expressions. And we're going to start with the filter statement. You can see the arguments here. It says the table and an expression. So we start with our table. Now we want to add the expression. We'll do the CapEx one first. Right? We did our expand equal to EOM. So let's hit run again. You can see down here it says 30 rows. And so what we have here is high fidelity rendition what is in the model. Now to actually do a computation, we're going to take this, copy it, but we're going to build a test measure. You can see this. We know this table works. This is a virtual subtable that's constructed in DAX. And so now we need an aggregation statement. So I'm going to illustrate how to do it with SUMX, and we'll have another version here in a little bit. So SUMX, you can see the argument is asking for a table. Well, we have our table, right? So now it's asking for an expression. Now, initially, we're going to use the canned expression, and I'll deviate from it a little bit. But so we have a number of canned expressions available, and we'll get into this in a little bit. We'll go cal capex, and you'll see how we construct that in a little bit. Check our formula. That works. Okay, and let's actually go test that now in our test pivot. And you can see measure one aligns very well with our canned capex measure. Now let's dig into this a little bit because we took a couple shortcuts here that were not really obvious. Let's go back into measure one for a second. What is this cal capex expression? Well, this is really syntax sugar for the following. We basically want to do a calculate, and we want to sum the calendarized capex column out of the model. I'm going to close that for the sum, close it for the calculate, and then close it for sum if and check the formula. Well, there's another way we could construct this. Call this measure two, and we're going to actually do the reverse. We're going to calculate the sum of our what? Calendarized capex, close that. So now we need a filter statement. We're going to filter it this way. Our calendarized, right? Here's our filter expression. Close it up and let it go. Measure two, and let's actually test measure two. Which one works best? They're comparable, but it turns out when you actually do the performance measures, SUMX beats it out by something like 2 or 3 milliseconds. So the benefit of having measures is that it's calculated virtually on the fly, as opposed to a permanent column living in the data model. So now we're going to take a look at what this looks like in a Power BI model. Okay, so this is the Power BI desktop application we're going to bring up. You can see we opened to the visuals page. So before we get into this, I want to just walk through this stuff a little bit. It's important to understand that this lives in two pieces. This is the desktop application, and this visual and these tabs get published to the Power BI service, which is accessible via the browser. This is the desktop version where the development occurs. So drilling into that, we have 3 layers here. Think of this as being the data model. This is where the tables live. We access that through the M code. Lives essentially this is the Power Query side. Various pieces of M code associated with transforming things. This is the visual side. The item I want to just touch on briefly, which we did not do earlier, is this visual here, which is the decline of the old and the growth of the new. This is actually surprisingly difficult to do with Excel, and is amazingly simple with the data model views. You can see here we got a measure table here that contain all the measures. Let's just pick up this thing for a second. You can see the syntax is we're taking the sum, going after the calendarized column. We're simply taking a sum of the new, and what this represents is an embedded calculate function. This then becomes a measure used in downstream calculations. For example, So this is the new. Let's go to the new. You can see we're taking SUMX here, which is the row by row aggregation. We're developing our subtable. So when the calendarize is greater than the when the expand is greater than the EOM, we want to accumulate it, and we're accumulating the this embedded calculate. We're accumulating those values, and what we end up with is when we do a test, this is the old and this is the new, and you can see the model is functioning. Model's functioning very well. It is important to do a validation and a test to make sure that you're getting the values you expect. Go back to our visual. We have essentially two visuals and a few slicers. The first is the decline of the old and the growth of the new in terms of the actual maintenance dollars, which is really tough to do, as I mentioned, with Excel. And then here we've got something that's a little easier and can be rendered in a table pretty easily. But you can see graphically, this is the slight growth in maintenance charges over the term, and then here's the associated CapEx by quarter. And of course, if we wanted to break that into month, it'd be easily done. We're not going to do that. It's a little more attractive visually here. And then we've got slicers. Everything is cross-filtered, and the slicers are hot. So here in AP, we've got 3 site codes. And we click on this particular site code and we can see the dollars and the activity associated. So clear, we've got 3 devices that are transforming. Here's the maintenance for that site, and here's the transformation dates. So that's the Power BI visual stack. Oh, one thing I forgot to mention, but is important. I want to draw your attention to this thing here, Microsoft SQL Server Analysis Services. So what we have running on the desktop at the moment is a modified instance of Microsoft's Big Iron SSAS database environment, the tabular side of that environment. This thing is about 1 gigabyte code, and it is, think of it as having 20 years of database engineering experience basically poured into this environment. Gartner is saying that they've overtaken Tableau and they continue to accelerate the gap versus the competition. And this is the analytic development tool of choice going forward. Okay, so now in terms of the view, let's look at the phone layout. You can see here we've got a phone representation. We've got some slicers, and we've got a data card. Save this and publish to the environment. You can see here this is the visual we just worked on. We're able to publish to the web, provide access via the browser. That's the Power BI. Okay, let's go back to the learning plan objectives, and I want to just summarize what we've learned in this video. First, we've learned to recognize the presenting data set, which is cross-tabulated tables. Second, we understand the key transformations needed to render a calendar view, specifically split the table between the row side and the depivoted side, and then depivot the cross-tabulated portion of that. We saw the extension of that. Understand the data model links, which is index number to connect the 2 sides together, and the use of a date table to connect date into the main view. We talked about why measures instead of calculated columns, net, bigger, faster models. We understand the DAX needed to render the expressions, specifically the filter expressions used to create virtual subtables, and then a piece of that, which is the Boolean expression across multiple columns. And third, the implicit calculate used as the aggregator inside the SUMX. And finally, why Power BI? We're using the SSAS tabular engine, and we've got cross-filtered visual. So all in all, a very powerful tool set to go forward. So that's it. Thank you for joining. Please give me a buzz if you have any questions or comments. Thank you.